Hello everyone, welcome to another STEM Helps video. We'll be continuing our discussion on two-dimensional motion. So let's say we have a sort of coordinate system. Let's say we have an airplane that is going 700 meters per second, very fast, and this angle is 30 degrees. So 30 degrees north of east. Sorry, east of north, sorry. 30 degrees east of north. I misspoke. And so we have wind that's pushing this, but it's a very small breeze. So it's 50 meters per second. And this angle is 60 degrees east of north. So now to the pilot, what direction is this going? Now we talked about just general adding if we didn't have any numbers, right? If I were to just ignore this, have a different color. If I were to just ignore this and have this plane, this is going to be a big vector, this is going to be a small vector, and this is very a quick sketch. So what we do is we kind of copy this as best as we can. This is just for visualization, right? And then we erase this, and now we continue on. So since we took this small velocity vector because it has direction and put it tip to tail to the first velocity, we can now say that the general velocity is going to be around this. It's going to be, let me have a straight line, going to be around this. It's going to be like this. So going back to our search, we have a different color. We can estimate that now instead of putting this here, just like adding vectors, we put this vector, because we know the numbers, it doesn't matter what the actual like precise direction is. And so we can have like a mini coordinate system, and so this is still going to be 60 degrees, hopefully, right? It's always going to be 60 degrees because all we did is just move it from here to here so that we can know the final velocity of the airplane. And so it's still going to be 50 meters per second. This is 50 meters per second. So now let me just erase this. Because seeing it twice might be a bit confusing to people. But just so you know that what I'm erasing, is already right here. It's just to visualize it better. Alright? Just nice now that it's cleaned up. And so now we can expect using without any numbers, we can visualize that this is going to be our final result. Okay? But let me just tell you right now, the math to do this in one component, and I'll explain what components are, is a bit difficult, and it's not easy to interpret. So what we do is, each line has some horizontal component, and some vertical component. So this one, for example, goes up some vertically and right some horizontally. We don't know what the numbers are. We just know that the final sum is equal to the sum of these vectors. So let me redraw this. This seems very, very cluttered. And I'll just draw a quick sketch because I'm not very good at drawing. So let's redraw this giant one here. it's still 700 meters per second. And we have this kind of, we can know the angle. This is still 30. And this is going to be 60 at 50 meters per second. 50. So now, if our final, let's look at this in terms of components of vertical and horizontal, right? So each of these vectors has this one and this one has a horizontal and vertical component. So just like this giant arrow goes up so much, we can determine that these two go up so much, and we can add these, right? So if we were to have a straight line, that would be equal to how far up or north this goes. So our goal is to try to find this vertical component and this vertical component and add them together, and so it would be the exact same distance as this. So how do we do that? Well, when I drew this line, you can see that this creates a triangle. And so we know the angle and we know the hypotenuse. Well, we can use a sort of trigonometry to find this out. So to make this simple in our just general understanding of trigonometry, we say that if this plane or this graph is 90 degrees at a 90-degree angle, if this angle is 30 degrees, then when you subtract 90 from 30, you would get 60 degrees. So let's first, we want to find the vertical component of this and then add to this. So first we're going to try and find the vertical component of this. So let's just have this as a triangle. If everyone is fine with that, we'll have this as a triangle. This is the actual line, and then we have another line like this at 60 degrees. And 60 degrees. And 700 meters per second. And I'll just write 700. So we want to find this. So what do? We know trigonometric functions have sine, cosine, and tangent. And just to have a refresher, SOHCAHTOA. SOHCAHTOA basically says what each trigonometric function does. Sine is opposite over hypotenuse. The cosine is the adjacent over hypotenuse, and tangent is opposite over adjacent. Now, why are we introducing these three concepts? Well, these are proportions. So just like we say that if I have 2 pumpkins for every 3 apples, how many pumpkins would I have if I have 6 apples? Just for example, if I have 2 pumpkins for every 3 apples, and I have 4 pumpkins, you would be quick to say 6 apples. We created a proportion. So that's exactly what we're going to do here. So sine of 60, opposite over hypotenuse. So opposite, we don't know. We usually in algebra we call x. So let's keep that pattern over 700. Now this is something that you can, number one, memorize because this is a 30, 60, 90 triangle, or go into your calculator and you'll figure this out. But if you want to find the other proportion, you need to know what the sine of 60 degrees is. And it turns out that sine of 60 degrees is a bit of a weird number. It is the square root of 3 divided by 2, or if you want to have an actual number, it would be around it would be less than 1. It would be less than 1 as an approximation. Alright, and so how would we solve for x? I'll give you a bit of time and you could try and figure this out on your own. Alright, welcome back. So how we solve this, let me erase this less than 1 here. So how we solve this is we solve for x, we multiply this entire thing by 700. X, let me have a different color. X is equal to 700 times the square root of 3 divided by 2. And you can put onto your calculator, and I got approximately 606.2. Alright, so we can have a general formula that says that if we want to find the height of something, we can say the hypotenuse, I'll just write as h. If we want to find the y component, we say times the sine of theta. And we use theta in trigonometry as a way of determining what the angle is. And to find the x component, we use cosine, and we'll get there as the problem progresses. H hypotenuse times cosine theta. Alright, so we're not done, we're halfway done. So the problem asks what's the vertical component. So we're halfway there. We got this part, now we need this part. So this is going to be 50, so let's have some room here. So let's draw another triangle. This is going to be our, I'm making it big so that I could draw more. And this is going to be our components, and this is going to be, this is going to be 90 degrees, and this outer area is, angle is 60 degrees, that means this triangle is going to be 30 degrees. And we know this is 50 meters per second. So we want to try to find the vertical component, again using our formula, or you can use, even if you forgot this formula, you can use SOHCAHTOA and figure this out. But we'll just go ahead and say the y component is equal to 50 times the sine of 30 degrees, which is equal to, well, this sine of 30 degrees, if you plug into your calculator, should give you 1/2. Here, let me write this bigger. 1/2. And so 1/2 times 50 is 25 meters per second. And so now we can add these two numbers up, 606.2 plus 25. $631.2 meters per second. I know I've been a bit off in the units. So what does this mean? That if we have a wind going 60 meters east of north, that means that if we add up how north it's going, it will be 631.2 meters per second. And in the next video, we'll be talking about how to find the horizontal component of other videos. But just as of now, I will go ahead and just tell you what the horizontal component is. And please pause the video and see if you can do this for yourself. Alright, so I got an answer of 393.3. So if this is going to be the horizontal, and by using the same process, I got x is equal to 393. I don't think this is correct, but just bear with me if these numbers are wrong. I'm sorry. So how do we, so like let's rewrite this. If we were to have a giant graph and we know that the x is going to be 393.3 meters per second and the vertical is going to be 631.2 meters per second, how would we find the hypotenuse? Well, by Pythagorean theorem, which says a squared plus a squared plus b squared equals c squared, where c squared is equal to the hypotenuse and a squared and b squared, you can pick which one. Addition doesn't care. So you can pick which one is a, which one is b, doesn't matter. So you can plug into your calculator and let's see if I can do this. 631.2. Now you take the square root. And I got 700. So what I did was I just C equals the square root of a squared plus b squared. And I got approximately 745.71 meters per second. So if we go to a problem, does this make sense? Does this make sense? If I'm going 700 meters per second and a wind is pushing with me, would I go faster? And yes, that should be the case. And I hope that's helpful.